Okay. All right. So, Stephen, if you're listening, Peter and I will. Peter gave me some very good questions. So I'm going to go through those ones first, and then it will be the mock exam one. Yeah, the tech-free mock exam, which you should have received by this time. So just spend 1 hour on that one after you've watched. After we reach that point, basically. Okay. All right. So the question is, what is it? Image. That one. Okay, all right, this one. Example 27. On any day, the cost per item for a machine producing X items is given by that equation there. So I'm going to rewrite that equation, right? So DC over dx equals to 50 minus 4e to the power 0.02x, I think.
Yeah, 2x.
Right? Okay. And then x is between 0 and 200. So when you get a question like this, you gotta like try to interpret the question first, right? So C is the cost in dollars. All right. Use the rate to calculate the marginal cost. So the idea of marginal cost, I'll use the notes that Peter's got here, and the idea of marginal cost is this. If you have C as the cost, right, then the marginal cost is dC over dx. Right, this is the marginal cost, which is the cost to produce one more item. To produce one more item. So I think this concept of marginal cost is definitely not the standard concept.
Yeah.
So if they were to ask this question in the exam, they would have to explain like, oh, the marginal cost is this.
Yeah.
Right? Yeah, so they won't just give you this question and ask you, oh, calculate the marginal cost, and nobody would know what marginal cost is. Because most schools, they don't actually learn this concept. Yeah, it's not part of the official term, but it could come out as long as the question defines what marginal cost is, and then they can ask the question. So for this question, I'll just define it here. So DP is marginal profit. So this one doesn't have the marginal profit, but then it's sort of linked anyway. So marginal profit is the cost to produce, is the profit received from selling one more item. So that's profit from selling one more item. One more item. Okay, and then the main function is the profit is the revenue minus the cost. Right? If you have a function for revenue, function for cost, it's just a function for revenue minus a function for cost. If you do get that kind of question. Okay, all right. Thanks for the notes, Peter. Now let's have a look at this question here. So let's interpret the questions first, right? So use the rate to calculate the marginal cost of producing the 100th item, which just means that for question A, it's just the, so if we call that C dash X, then this is just going to be C dash of 100. All right, so X is item, yep, okay? Just C dash of 100. And then the total cost of producing the first 100 items is going to be anti-derived between 0 to 100, right? It's like the idea of if you get velocity and then you anti-derive velocity. When you anti-derive velocity, you get the distance, the change in position, right? From between two values, like between 2 times from 0 to 10 seconds, you actually get the change in position between 0 and 10. Change in position. Okay, if you do that antiderivative with respect to time. So from 0 to 10 seconds.
Displacement? Is it displacement or changing?
Change in position, which is displacement. So displacement is like final position minus initial position,
so
right?
Distance. So what about distance?
Distance, you need to think about signed area. So okay, that's a good one. For example, right? Let's say the velocity graph looks something like this. Like that, right? From 0 to 10 seconds. If you anti-derive, this is positive, negative, positive, which means you get a signed area, right? So which is the absolute position, because if it's positive means the particle's moving to the right, and then negative means to the left, and then positive moves to the right again. So it will move like dot, dot, dot. So see that? If you anti-derive it, this is the displacement. right? The absolute change in position. So if you want the distance, you need to find where it cuts and then calculate each area and then flip it if it's negative.
Yeah.
Right? That would be the distance, which is that line, this line, and then that line there.
Yep.
Right? Given this example here. Okay, so very good point. Now back to this question though. So the cost of producing the first 100 items would be n derived from the item 0 to item 100 of the C dash x equation with respect to x. Okay, so that's the general idea. And then the average cost of production. So average cost just means you get the total cost and then you divide by 100.
Yeah.
Right, so it would be answer from B divided by 100. Does it make sense? Yeah. So I can go through this one. So for question A, right? So first we need to go let C dash x equals to this. So we have to define a new notation. And then A, C dash of 100 would be 50 minus, so 4e to the power, so 100 times that, just e squared. All right. And I'm not sure if is this a calculator question? Peter?
No.
No, so tech free, right?
Yeah.
Okay, yep, that's fine, we can do that. So let's see. Yeah, okay, that's fine. We'll leave it as exact values. And then the total cost would be n derived from, so I'll write it as total cost is the antiderivative of 0 to 100 from item 0 to item 100 of the rate of the marginal cost of producing each item. So C dash of x dx, and that would be n derived from 0 to 100 of the equation 50 minus 4e to the power 0.02x, and then that would be, so this one is just one antiderivative, so I don't actually need to do any big f of x or anything, right? So just square brackets. 50 becomes 50x minus, so e becomes the same thing to the power 0.02x, but then you're going to divide by the coefficient of x, which is 0.02, like so, from 0 to 100.
Yep.
Okay, all right. Now let's just work out on the side here. What's 4 divided by 0.02? It's like divide by, and then that's 2 over 100, right?
200.
Which is 4 times by 100 over 2. Cancel out this one, gets 2 times 100, which is 200. Okay, now let's do all this simplification first before we continue. Because look, if you got 50 and this one is 200, you can technically take out the 50. Right? It'll make the calculation a bit easier. But for now, I'll just write step by step. 200 e power 0.02x from 0 to 100. And then to make my calculation easier in the tech-free environment, take out the 50. So x minus 4 e 0.02x from 0 to 100. But note that when you take 50 out, right, just make sure you put double brackets, yeah? So when you sub 0, it will be 0 minus 4 times e to the power 0 is 1. So just that. Actually, sorry, it should be 100 first. I have sub 100 minus 4e, and that would be squared. Okay? And then when you minus sub 0 would be this.
Yep.
Okay? So note the 50 is always still at the front here. It'll be in front of the big brackets. So that's 50, and then, all right, let's expand the bracket. So that will just be one brackets now. 100 minus 4e squared, and then minus 4 is plus 4.
Yep.
Right? So that will be 50 times by 104 minus 4e squared. Well, I think you can potentially leave it this way because it's like a factorized version. You know, it's actually a bit more simple. Can even take out, 104, can take out 4. So that would be, if you take out 4 from these two numbers, that would be 200 at the front. And then divide that by 4. 10 divided by 4 is 2. Remainder 2 divided by 4 is 6 minus e squared. Okay, so that's the total cost to produce the first 100 items. And then the average cost of production, essentially, is just that cost. So C, average cost of production would be this cost, the total cost, 26 minus e squared over 100. And look, convenient. Bam, bam, cancel out. That would be 2. So that's just 2 times 26 minus e squared. All right. Should be the final answer. Cancel that, you get 2. Okay, any question, Peter?
No.
No? Okay. So yeah, so that's an example. This is a really good example of understanding the idea of the marginal cost of something, and then you anti-derive the marginal cost, which is the cost to produce one more item at that number of item. So this is an interesting one because when you look at this graph here, right? What's the shape of this one here? So you don't need to actually do this for that question, but let's just think about it. Minus 4 means reflection. So plus 50, right? Let's analyze this graph here. Plus 50 means the new asymptote will be y equals 50. Something like that. Yeah? Okay? Oh, actually, maybe I'll use a bigger space. This is a bit small. Okay, maybe I'll use this one here. Alright, so the graph is shifted up, and then what's the shape here? The minus in front. So normally it's like that. Just think about it, when you minus in front of the y, it's each value maps to the negative, so it flips in the x-axis. So it should look something like that, and then that's the asymptote. The new asymptote will be at y equals to 50. Alright, then let's just quickly graph that out. So that will look something like this. Okay, so the marginal, let's say the marginal cost of producing the 100th item. Alright, so looking at this one, right, what we can see here is at the first item, it costs a lot more to produce. Right, so when x equals to 0, let's say that will be 50 minus 4, which is 46. So it cuts this one at 46. Right? Okay, so it's saying that the first item, so when x equals to 0, to produce like one item, when you have 0 items, it costs $46. But then the more you try to produce, the cost lowers. And let's see, so from 0 to 200, because if it's more than 200, it doesn't make sense. That's what they're saying. Right? So for the first 200 items, it gets to that point, because I'm pretty sure if you were to calculate that value there, it should be about 200 something. Let me just quickly have a look. So let's substitute 200 into the equation to find out what the y value is when x equals 200. So you get like 50 minus 4e to the power 0.02 times 200 is just power 4.
Yep.
Yeah. Okay, let's say 50 minus 4 times e power 4 is... It's 4e power 4, right? Okay, double check. 0.02 times 200. Yeah, okay. So that's negative 168. Bit strange. Negative 168. Hang on. Let me double check the... Huh, interesting. Marginal costs. 50 minus 40. Okay, let's just find out what it is for the question A. 50 minus 4 times e squared is 20. Oh, okay. So it's about $20 for the 100 item, and then for the 200 item, it goes negative. That's actually pretty strange, because normally they would cut off over here. Normally. Yeah. Anyway, so the answer for this one is actually negative 168, which is like somewhere way down here. So they're saying, so this model is saying that when x equals to 200, the cost is actually positive. It's actually, you know, they actually make money producing, which to me it doesn't really make sense. The cost, there should always be some amount of cost and not negative. But anyway, that's the question. You know, I don't know if they have checked it. Let me just check what happens when the marginal cost is 0. So that would be negative 50 divided by 4. So that would be 50 divided by 4. And then 12.5, and then ln of that. ln 12.5. And then divide by 0.02. Okay, so I just found that when x equals to about 126, that's when the cost is 0. So this point here is actually 126.29 or something, that point there. All right, x is that, y would be equals to 0. So after that, I don't think the model makes sense anymore. But anyway, maybe that's why they don't ask you guys, they don't ask you to sketch this graph here, because it actually doesn't really make sense. That's why they only ask for the first 100 items. So what they're saying is that this is the marginal cost, and as the number of products increases, the cost to produce lower. It's kind of like say thinking, you think about it, right? If you want to produce the first iPhone, it costs a lot because you need to set up everything, right? But then if you want to produce like 1 million iPhones, like the first 100 will cost a bit more, but then after that, it's just let the machine run.
Yeah.
Right? It's actually not that difficult anymore. So that's why it's something called in economics called economy of scale, which is the idea that the more you can produce something, like the cheaper you can produce it.
Yeah.
Yeah. So yeah, so that's economy of scale. You want to have big scale. That's why big companies are hard to be replaced because they already have such a big scale, and so they can do things for such a cheap price. And there's an example of economies of scale. Very good example. Hi, Peter. You have any other good ones for me?
No.
No? Yeah. Alright, that's fine. So let's go back, continue working on the rest. And now it's time to do the mock exam 1 tech free. So I will, let me think. Okay, I will just put up the timer. But yeah, Stephen, if you're listening to this, right? I'm going to stop this recording, this first part of the lesson, which is because the next 1 hour is just going to be doing exam time. So just set yourself 1 hour and work on this paper. All right, and after that, watch the second recording, and my explanations will be in there.